Welcome back. Today we're going to hold a conversation with our chatbot and see how well it does. So let's start out with our chatbot up and running exactly as we have it from the last video that we worked on. So let's start with some simple questions. See what the bot has to say. Now, of course, recapping the process, we asked the question and the program went out to the AI service, which is OpenAI, and it got the response. And we see the response on the screen now. Let's ask it another question. So far, all fine and good, and it's providing the information we're asking it. But now, let's get down to the nitty-gritty. Let's really test the abilities of the conversation. We have a problem. The whole point of conversation is being able to remember the conversation. And right now, our beautifully simplistic bot simply can't do that. That is a severe problem, but it's not one that we can't solve. In fact, it's very easy to solve as long as you understand a few basic rules. So let's get up my magic marker graffiti system and start doing some dribbling on the screen. Conversations in AI are broken down into a reference point of user and assistant. User is you. You are the user of the system. Assistant is the machine, the response. In the case of what we have done, this is the user, whereas all of the content provided by the machine is the assistant. These two factors can be used and combined in a simple Python list, where we actually keep track of what the user asks and what the machine gives as a response. This is very easy, but there's never anything that simple in life. Because as we develop and grow and ask questions, we run into another problem. And that is, at some point, the AI is going to run out of memory. And that can be a serious problem. We are now going to see what happens when we can keep a conversation. You'll notice we have a new bot to work with. And the personality still has the consistency of watching wet paint dry. But that will be dealt with in the future. For now, let's see what we can do. and see what kind of questions we can answer. Or I should say, what kind of questions it can answer. And actually hold a conversation. Okay, it's a nice, simple recipe. Let's ask a second question. And now let's ask a third. Now let's actually see if it can remember our conversation. And lo and behold, it did. It remembered our conversation. We have 3 questions we gave it, and it remembered all 3 questions. So it's building the memory, but at some point, it's going to run out of memory, and we need to have a way of keeping track of what we give it. In terms of the AI engine or service, this is called a context size. It is much like our short-term memory. There's only so much it can remember before it has to get rid of something old or it breaks. Right now, this particular program is set so that it doesn't have a limit, and it will just continue to add up over time as we continue to ask questions. And we are eventually going to run into this limit. Let's see if we can actually break it. For all those out there that deal with literature and other world events, let's see how it responds. And we can even go through and ask it to be thorough. In other words, we want to actually take and have it use as much memory as possible to fill up that reservoir between the user and assistant. Because what happens is we are building a list of user, assistant, where each question and answer begins to accumulate in that profile. Subsequently, so that we continue to grow in size of requirements. And of course, here is the nice, wonderful answer it gave us. Now let's ask it another question. And yet again, we have some more wonderful text that is taking up more and more memory. This is just a brief interlude as I continue to try to fill up the original memory pool that the OpenAI service has. It gives a 128,000 character limit, which is quite generous, to be very honest. But over time, as you continue to fill it and the conversation grows in length, it will eventually get full. And we will see if I can actually accomplish that before I resort to more drastic means and simply try to stuff the system with additional heavier questions. The memory does work extremely well in its base form. And as you can see, I've already asked 8 different questions, with the healthcare issue being 3 questions really, as it's given a lot of information. Research-wise and educationally, this is the world's libraries at your fingertips, and it's amazing. So let me get back at it and see if I can fill it up. Okay, after what seemed like an unusually long amount of time, I finally have broken the AI's memory. This particular model I'm using has a much smaller memory. As we can see from the error, it only allows 16,385 tokens. Now, a token is an interesting representation, and it is defined by a mathematical equation. We're going to get into all of that, and we're actually going to see how to fix this problem. When you are using your AI model for conversation, as you can see from the amount of time it's taken me to actually fill it up, it's very robust. Overall, though, each model has its own context size. Some models are very large, like GPT-4o, that have 128,000 for a context size. This is quite generous and really an incredible way of developing a conversational model like we are doing. But other models are more specific and have a very fine-tuned memory set that only allow 4,096 for a context size. These models are geared for scientific or mathematical exploration. Now, context size alone does not make one model better or worse than the other. As we get into other services in the future and we start looking at different models, they each have their advantages and disadvantages. I like the 4.0 mini from OpenAI because I like the conversational context of having it being able to remember large amounts of conversation and being able to refer back and forth to the incredible levels of context and information in building that conversation. It really is a wonderful resource. Okay, I have made the changes to the program, and I have brought up a quick reference of what we have talked about. But let's actually look at the memory layer itself, the actual list of what the questions I have asked and what it currently has in its context. This is the file that the user assistant responses are stored in. And right now there are 37 lines of information. Looking at this file, we can see combinations of user and assistant where I've asked the question and then the AI has responded. Over the progress of time, this file grows, but each time we make the AI call, all of this information is given back to the AI so that it can evaluate and follow the conversation. Unlike the human brain that stores everything and can retrieve it, the AI is a little different. It can't store and retrieve information on its own for a particular conversation. So that relies directly on our own bot, our own process, as we have done here, storing the information so that we can then recall and use it within the program itself. Now we're going to get into this program and really take a look at it. It's a fascinating approach, and as you can see through the depth and construction of what we are doing, you can really build a very rich conversational model. So let's get into that process and actually see and dissect this program. In order to explain this program properly, we're going to have to do a little bit of jumping around to go through to make the logic of it clear. So let's start at the bottom where the main function is. This is not that different than the original program we were working with. The only real difference is instead of communicating with the AI directly, as we did with the previous program, this program goes through another layer that actually manages the memory process. And that is the biggest real change that this program has. And it's quite a bit more in depth because of that. So let's go up and actually get to the Babel program, or the Babel function itself, the actual memory part of the program. So it takes the same input text as the AI model directly, but instead we initialize several lists and we check for the memory file. The memory file is where we store the conversation between the user, you, and the machine, OpenAI. We have a function that reads this file and puts it into the list. Nice, simple, and short. And then we simply merge that into our primary list. From there, we take and we read the list and convert it to a JSON format. A JSON format is a key value format. And in the case of what the AI engine wants to see, the format is on the basis of curly braces. And then from there we have the user or assistant, and then the content, the message, question, response that we gave, which we saw in the memory file a few seconds ago. This is just a convenience way for which the information is stored. It's a simple process, really, and one that makes what we do very efficient. So once we've loaded the memory, then we add the most recent question to the memory itself. And now the big change. We actually go through and using that mathematical equation, we count the number of tokens and we adjust the memory appropriate to what the model will hold. Now 128,000 tokens is a lot, but what does that really mean? Well, that means that we can take a phrase. Let's take hello there. And now hello there is 11 characters. As a crude representation of the example, let's say one token is 4 characters. That means this simple sentence would be 3 tokens. Hello there would be 3 tokens. So if you have a context size of 128,000 tokens, then you can safely take and multiply that number by 4 to give you a rough idea of just how many characters you could have, which is basically 640,000 characters. That is a lot. Now the mathematical formulas that OpenAI provides for Python does all that for us. And the more modern models like GPT-4 actually do a very efficient way where entire words can be converted to tokens. So it gives us a way to really hone in and figure out exactly what we are truly using. So with that being said, and we see that context, once we get the memory that has been set to the size of the AI model, we simply pass the entire memory into the model for it to evaluate. So it has the whole conversation, the history of it that it can then take, and based upon all that information, come up with a meaningful response. From there, we add the response to the memory, and make sure it is in the memory file itself. Now, as a safety check, if the response is empty, meaning there's an error, whether it's a connection or whether we've overextended our tokens, whatever, if it's an error, we don't want to actually store it to disk. But then afterwards, after we have done everything and we have a nice, pretty response, we add that response to our memory file on disk. That is, we just keep building and adding. Now, eventually, this file is going to become monstrous. And you can limit it to the last 100 lines, the last 200 lines, whatever you want. There are innumerable amounts of ways of doing it. But for now, we're just going to keep it simple and let it grow forever. It's really that simple. The token reduction process handles this for us, so we don't have to worry about it. When we get to Companion itself, you'll see how we actually handle the prospect of separating the memory from the token list so that we keep 2 separate lists as needed. So when we save our memory to disk, we don't actually end up losing information along the way. But for now, this is a nice, simple, and easy model to follow, and it helps build the necessary information as we develop our bot's memory. And that really is it. Once we save the memory to disk, we return the response back to the main program that gets printed to the user. But the magic of the tokens is in this function. And it's a complicated function, to be quite honest. It goes through a lot of things. It goes through a lot of steps. So let's go take a look at it and actually see what it does. So here we are. The maintain token limit. It takes the original messages, the maximum tokens, and the model. Now I've set this up so we can actually build on it in the future, where we can use this one function to handle any model we want to give it. We don't want to work on the original messages. We want to work on a copy. So that's all this line does. We simply copy it. But from the standpoint of the model, from the standpoint of OpenAI, we need to tell it that we want it to count tokens, and we want it to actually take the input we give it, which is all of the messages up until this current point, and process them so that we can count the tokens. Token counting is actually done here. We actually break down the message in JSON format, and we take the content body. That is, we look at the actual information, whether it's question or response, and we add it all together. So what that means on the basis of our actual memory file, let's take one of these. The information that is actually being examined is strictly the content field of the data set. That is, we don't care if it's user or assistant at this point. We need to take whatever was provided and get the number of tokens from it, so that as we progress, we can count and continue and see where that actually goes. That's the whole point of what this function does, is it adds up all of the tokens of this entire file. And then we compare it to see if we are within the limits of the maximum. Now I've put a safeguard here for testing, so that if I pass in max tokens of 0, it doesn't process anything. This lets me actually test the AI model with no filtration. But now we get to the big part. Now we get to the workhorse, and really the hardest part of the entire function. We actually deal with what happens if we have too much information and we have exceeded our context size. This requires a little bit of tediousness, because we need to actually remember what we're doing and examine the actual memory file. It also means we have to deal with problems that might have corrupted the memory file to begin with. For example, as we look at the memory file, we can clearly see user and assistant constantly stippled throughout the file. That is, we have one user and one assistant, after the other in each block. Each combination block of user and assistant is actually one whole question. So user-assistant combinations allow us to actually be able to remove the oldest before we add the newest. That is important. But what happens if we have a user-user combination, meaning the file is damaged and we don't have an assistant response? Well, that's very simple. We don't want to damage the file more, so we only pull off the top user level. But if we do have a user and assistant model, then we pull that whole combination off. From the standpoint of the for loop, we are walking the whole list, and we are doing so with one less in the range, because we are comparing two elements at once. The current element, which should be a user, and the second element or follow-up, which should be the assistant response. So as we continue and we walk through this list, once we remove one message, we break it all together. We get out of the for loop and we reevaluate the token count. We don't want to cannibalize the entire memory. We want this to be a controlled process where we keep as much memory as possible. But we're not done yet, because we have a problem that we have to address. And that is, what happens if we have a model that simply can't handle what we've given it? Meaning that the old token count and the newly calculated token count are the same. Well, then the context size is too small for this memory set, and we break the program. Now, in Companion, that's handled differently, but for now, this is the only way we can deal with it. We just break the program and exit back to the prompt. If we have a reduction, then we remember what that reduction is. And in the event that any unwanted surprises come up, we document where the error is and exit the program. So this really is the workhorse of the program now. This is the bread and butter of the conversational part of our bot. It seems complicated, but as you get used to the idea of working with tokens versus whatever you are typing, it's really not complicated. Now let's go look at the AI model itself, and you'll see that it's not that different. We've only made one real change. Instead of pushing it a single line of input, we now push in the entire memory that we have, and then we give that entire memory block to OpenAI. That's really the only changes we've made in this function. Is instead of a single line of text, we're now dealing with entire levels of memory. And of course, helper files for reading and writing the files. Simple stuff, really. But the big part of the program, the part that actually puts the conversation into conversational is right here. This is the big part of the program. Without this, you can't have a conversational bot. So you need to be able to keep the conversation going by taking the oldest item out of the box and putting the newest item in the box. But that brings up a lot of questions. For example, if we look at our memory box, it's going to get filled up sooner or later. Unlike our human brain, AI models don't necessarily have a long-term memory yet. They have just this one short-term memory reference. So whenever something goes into it, at some point it's going to fill it up. Unless something comes out of it. And how we take something out of it is debatable. There's actually a lot of different ways. For simplicity, I chose simply taking out the oldest item, the topic that I haven't talked about in the longest. But that's not always a good approach. A better approach might be to look at the items and correlate them and then take out the item content that does not relate to the current topic. So there are a lot of different nuances that we can look at in how we manage the bot's memory. Overall, though, I personally believe that the oldest item is the easiest one to implement, and it still provides a richness for the memory itself that lets us really converse with the bot. At this point, we have a bot that will converse forever because it will automatically manage its memory and manage the information we give it. So we don't have to worry about running into errors about the context size of the information we give it. So we can ask it questions, and we can even ask it things about those questions. For example, let's start by asking it to limit its responses. So there we are. Now we can actually go through and ask it more questions. For example, for those that are Star Wars fans, we can go and ask it even more interesting things. But we have the limit of one paragraph that we gave the model. So this means that for long requests, in the case of what we have on screen here, we can actually limit the amount of information that the bot will give us for readability. When you're working with a Discord server, you can use this to your advantage because Discord has message limits of only 2,000 characters. If you don't want to actually write a message splitting function that can spread out larger requests across multiple messages. But as we look at this, we could even do some very interesting things. And because of the context of the memory of the bot, we can actually get it to fall into a role. Much like the Koikai example I demonstrated from my own server. This role now lets you achieve an immersion for your server. You have literally the beginning points of building a character in your server that can add to its richness and develop reasonably well. Now, you do need to be aware of copyrights and things of that nature. If you choose to model a character after a Star Wars figure or a Warhammer character, so forth, you'll want to be careful not to emulate that character completely and exactly because of those copyrights. But we can take this information we have right now and we can build on it even more. Let's see, how do we want to really take this to a new level? And we have actually begun building something entirely new. Something that we can enrich our space with. That we can actually begin to build on and breathe life into, so to speak. Much like the characters of a novel, once you have the conversational part down within your bot, you can really begin to build on its representation. And that brings us to one particular part of the OpenAI system and really any well-built large language model. And that is what is called the system role. We've seen the user, the assistant, but we can also have a system. The system role is kind of what I am building here. The representation of what our character is going to be. Now, we're not going to go into it very in depth here, but I wanted to demonstrate just a little bit of what is possible, because we are going to be building a full, complete system role that gives our bot a personality. That is, it's not going to be like talking to something akin to watching wet paint dry. You'll be able to build onto it to create a richness that makes it fun to communicate with. This goes back to my premise from the very beginning in the welcome, that we can't avoid dealing with AI. It's infiltrating every aspect of our lives. But by going through this type of shaping, this type of immersion, we can make it enjoyable to communicate with. We can make it functional. We can actually have it add and provide value to our lives. I still despise computers on a telephone, but at least if it makes an effort to try to communicate with me, maybe I won't despise it as much. That is the hope that I would like to see Companion unleash, both in Discord servers and even in the real world. The ability to give a life to the machine that just doesn't infuriate you from beginning to end. We will continue this whole series a lot more. And now that we've got the conversational part, next time we need to deal with the Discord part. We need to actually build the Discord chatbot. And that will be the next video, to actually piece it all together and show how this can actually come to life. How we can take the representation of what we've built and turn it into something helpful, meaningful, educational. For example, now that I have a representation of a style, let's ask it a question. We remember just how bland and boring the response was from the original models. Now we can see that we are beginning to get a bit of depth to our responses. This is really just the beginning of just how far we can take this. And to be quite honest, this is where the fun begins. Being able to actually shape the character, to mold it, to build it into an embodiment that is fun to talk to. It's an entertainment that can enhance your server immensely for both you and your members. And what makes this even more enjoyable is you can build moderation functions into this to help you maintain your server. And that is what we are going to really tear apart within Companion. Because this is just the tip of the iceberg as we continue. Share your thoughts. Let me know what you think of the ability to be able to build a personality into the machine. Ask questions, leave comments. The links for the Companion repository, including this program, will be in the description below. If you would like to help support this kind of research, please become a sponsor, because it does help cover the costs of running and maintaining the services and VPS involved. Thank you for watching, and until next time.